Okay, in example 3 and 4, we are still doing trigo integration, but we are integrating the things that doesn't fall into the basic two blocks of formula. So when it doesn't fall into the basic two blocks of formula, sometimes we need to use our double angle. So there will be a use in double angle when we cannot integrate things that fall into the basic two blocks of formula. Okay, so I need to show you how we are going to twist the double angle and eventually get to the basic block of formula. So if you look at example 3a, this is a product. So if this is a product, I don't have a product rule for integration. So in that case, right, I got to twist from this double angle. So if I twist from this double angle, I will have, so you think of it this way, 2 sine x cosine x is sine 2x. Then you divide the 2 over. So when you divide the 2 over, it gave you the equivalent formula. That means, right, integrating sine x cosine x is actually equivalent to integrating sine 2x. And that brings me back to the block of formula where a is 2. So the second block of formula. So I will go for the second block of formula. I will get a -1 over a, and I will get a cosine 2x. Okay. So here you will get a -1 over 4 cosine 2x plus c. So you need an extra twisting, and we are twisting it from the double angle. Okay, so can you see I twisted back to the second block of formula, this one. Okay, so there's a lot of twisting that you actually need to do. You do not need to show the twisting. You just need to be able to twist. Okay, so for example here, the next one is a cosine square. So if you look back at the block of formula, there is no squaring except for secant square, but it doesn't have anything on cosine square. So in that case, I'm going to twist from this double angle. So you're going to twist the double angle. So you can twist it slowly. And then you slowly divide by 2. So you divide everything by 2. So this is the equivalent of a cosine square. So find the equivalent formula of a cosine square through double angle. Because if I can do this, I will get to the part of the second block of formula where a is 2. So because of the twisting, I can get back to the basic block of formula. Then I go on for my integration. So I will get a 1 over 2 sine 2x plus half x plus c. So that's it. So the idea here is, right, if you cannot integrate using the basic two blocks of formula, you need to do some twisting. So same for secant square. So if there is a secant square here, I need to twist from this double angle. So you twist from the double angle. Okay, so there's a lot of twisting that you will need to do. Okay, and then you divide by 2. So after you twist from the double angle, you will get the equivalent of sine square. So integrating sine square become the same idea as integrating the equivalent formula from the double angle. And again, it brings you back to the second block of formula where A is equal to 2. Then you integrate as per normal. Okay, now you realize that ABC, right? I'm manipulating for the double angle. But in tangent square, the next one, I'm actually not manipulating from the double angle. So there is one basic formula that is given in your O-level formula list. I'm actually twisting from this basic formula. So if I twist from the basic formula, this is the equivalent formula for tangent square. So I'm changing it to this one. Reason because I know how to integrate a secant square. So secant square is part of the basic block. So if I integrate secant square, I just get a tangent x. Okay. So there's quite a bit of twisting here, particularly using the double angle formula. So in example 4, I'll be twisting from the double angle, but it's actually more difficult. So for example here, for 4a is sine square 2x. So I should be using this formula to manipulate. But then the angle here is 2x. So the angle here is 2x. You will need the awareness, or you need to remember that you can actually double up your angle. So you need to double up your angle first. Then you can do your manipulation. Then you can get the equivalent formula. So this will be the equivalent formula. So I will be integrating half minus half cosine 4x. So I go back to the second block of formula. But in this case, my A is 4. So that will be my second block of formula. So my second block of formula will be a 1 over A sine 4x plus C. So this has an additional layer of manipulation. You need to remember the property of double angle, which allow you to double up. Okay, so I'm going to erase this part. Make sure you copy this. Because in the next one, cosine square, it will be the same manipulation. In the next part, we are using the cosine 2x, 2 cosine square x minus 1 formula. But because the angle here is half x, so I need to change the angle accordingly. Change it to half x, and this part will be changed to x. So once you change to x, you do your manipulation. You do your manipulation, you divide by 2. So remember the double up, then you can get the equivalent. So integrating cosine square half x is the same as integrating half cosine x plus half. And that is again back to your basic block of formula. So when you integrate cosine x, that's just a sine x. Okay. So it's almost the same like example 3, but you need one more layer of twisting for your double angle. So just now for this part, for tangent square, just now I used back a basic formula. So I'm also going to be using back a basic formula here. Okay, so this basic formula is applicable when the angle are the same. So when this is x, this is x. So similarly, if I would like to change it to 3x, then the secant square also change to 3x. So the basic formula needs the angle to be the same. Whereas for double angle formula, the angle is actually double. Okay, so that is a feature of double angle formula. So basic angle needs the angle to be the same. So we can twist the basic formula and I will be able to get the equivalence of tangent square 3x, which is secant square 3x minus 1. Then I go back to the basic block of formula. A is equal to 3. So I get back to the basic block of formula and I'm able to integrate. Okay, and this one, just now when we are trying to do sine x cosine x, we use sine 2x double angle. So this one is the same idea. This one, if you explore a little bit, you just explore the number 6. In a way, you break the number 6 to 3 times 2. When you break that successfully, this part is your double angle. It's your double angle sine 2x. And that will bring you back to your basic block of formula where A is 2. So when A is 2, the formula is minus 1 over 2 cosine 2x. So you will be able to get it out. So you only need to use this manipulation from double angle or the basic formula of 1 plus tangent square equals secant square. Only when your integration of trigo doesn't fall into the basic block of formula. Okay, so this one is a bit difficult because it's quite a bit of twisting.